press the bell icon on the YouTube app and never miss another update.
Hello everyone, welcome to the class. In the last class, we were discussing about some JEE mains level questions from the chapter 3D geometry. Let's continue the same thing here. I think we have discussed 19 questions in the last session. So let's begin with the 20th one. So let's move to 20th question. 20th question is like this. The cosine of the angle A of the triangle with vertices. Yes, here we have three vertices of a triangle: A with the coordinates 1, minus 1, 2, B with the coordinates 6, 11, 12, and C with the coordinates 1, 2, 6. Then what is the cosine of the angle A? You mean cos A. So let us draw a triangle. Let's take this one as angle A. This is B. This is C. Now A is a point. A is a vertex with the coordinates 1, minus 1, 2, and C 1, 2, 6. And B with the coordinates, yes, we have 6, 11, 2. So in this case, we to find what? The cosine of the angle A, you mean you have to find cos alpha. Sorry, we have to find cos A, you have to find this. So for this, let me find the ratios of the lines AB and AC. Yes, the ratios of the line AB are given by, yes, direction ratios of a line joining 2 points. If you take this one as x1, y1, y1, z1, x2, y2, z2, then x2 minus x1, you mean 6 minus 1, 5, and 11 minus of minus 1, 12, and 2 minus 2, that is 0. So these are the direction ratios of AB. And ratios of AC, same as before. X2 minus x1, you mean 1 minus 1, 0, y2 minus 1, 2 minus of minus 1, that is 3, and 6 minus 2, 4. Or you can write this one as in vector form, 5i cap plus 12j cap plus 0k cap, like this. Your choice. Then we know that the angle between the two lines, we have to find cos A now. So I taken AB and AC. So now the formula is what actually? So A1 A2 plus B1 B2 plus C1 C2 whole divided by root of A1 square plus B1 square plus C1 square into A2 square plus B2 square. So this is a formula to find cosine of the angle between them, you mean AB and AC. So let's substitute the values. This gives what? A1 A2. Let us take these as A1 A2, A1 B1 C1, A2 B2 C2. So A1 A2, that is 0 plus, so B1 B2 36 plus gives 0 whole divided by root of this, root of A1 square plus B1 square plus C1 square, you mean 5 square plus 12 square plus 0 square. So you get 25 plus 144 plus 0 into 0 square plus 3 square plus 4 square. So you get 9 plus 16. So you get 36 whole divided by root 25 plus 144 gives 169. So 116, root 116 is 13 into 9 plus 16, that is 25. So 5. So you get 36 divided by is 85. That is the answer, 36 by 85. I think option number, sorry, 6 by 85, sorry, 65. Yes, 36 by 65, that is what the cosine of the angle between the lines AB and AC. So your option is option number 2. So second option, the correct one, 36 by 65. Yes, so let's move on to question number 20 first. Question number 21 is like this. If the line joining the points K23, 1, 1, 2 is parallel to the line joining the points 5, 0, 5, 4, minus 1, 3, 2, minus 3, then what is the value of K? So, I mean that these two lines are parallel to each other. So, we know that the direction ratios of the line, direction ratios of two parallel lines are in same proportional. So, here we have two lines. Let us take first line AB, I mean first coordinate as A, K23, A as K23 and B as 1, 1, 2. Let us take C, a third point as 5, 4, minus 1 and D as 3, 2, minus 3. So, they have said that lines passing through these 2 points AB and CD are proportional for what value of K. So, now let us find the ratios, direction ratios, ratios of AB. Direction ratios of AB are given by same x2 minus x1, 1 minus K, y2 minus y1, 1 minus 2 that is minus 1, z2 minus z1 that is what minus 1. And again direction ratios of the line passing through C and D. So, you get again 3 minus 5, 2 minus 4 and minus 3 minus of minus 1. So, minus 2. So, minus 3 plus 1 you get minus 2. So, these are the ratios of the line AB and these are the ratios of the line CD and they have said these two are parallel. So, we know that two parallel lines, I mean direction ratios of the two parallel lines are in the same proportion. Therefore, I mean A1 by A2 equal to B1 by B2 equal to C1 by C2. This gives, this is A1, B1, C1, A2, B2, C2. So, 1 minus K by minus 2, minus 1 by minus 2, minus 1 by minus 2. So, this gives what? 1 minus K by minus 2 is equal to 1 by 2. So, or you get from this 1 minus K is equal to minus 1 to get cancelled on both sides. So, you get K is equal to 1 plus 1 that is 2. You mean the lines passing through AB and CD are proportional for K is equal to 2. So, option 2 is the correct one. Okay. So, this is based on what the result, I mean direction ratios of two parallel lines are always in the same proportion. So, using these results we have found K. Okay, let me move to the question number 20 first. Sorry, question number 22. Yes, in the question number 22 we have three statements. First statement is what? If theta is angle between two lines whose direction cosines are L1 M1 N1, L2 M2 N2. So, then cos theta is equal to L1 L2 plus M1 M2 plus N1. Of course, this is true statement for any two lines with cosines L1 M1 N1 and L2 M2 N2. So, cos theta can be found, I mean cosine of the angle between the lines can be found using the result L1 L2 plus M1 M2 plus N1 N2. This is standard result we have. So, this is true for any two lines with the cosines L1 M1 N1 and L2 M2 N2. And the second statement is what? If L1 M1 N1 and L2 M2 N2 are the direction cosines of two lines, then this happens. I mean the value of L1 L2 plus M1 M2 plus N1 N2 whole square plus L1 M2 minus L2 M1 whole square plus M1 N2 minus M2 N1 whole square plus N1 L2 minus N2 L1 whole square equal to 1. So, of course, this is also true because in vector algebra we have discussed the result that for any two vectors, we know the result that A cross B whole square plus A dot B whole square gives magnitude of A whole square into magnitude of B whole square. This is a standard result we had discussed in the previous chapter, that is what vector algebra. Now let us take vector A is given by, or yes, they have mentioned line. So here I am going to take as vector A as what, L1 I cap plus M1J plus N1K, and vector B I am going to take L2 I cap plus M2J plus N2K. So now, let's find A cross B first, or before that A dot B. So A dot B gives what actually? So A dot B is equal to what? Dot product of these two. This gives what? L1 L2 plus M1 M2, yes, plus N1 N2. Then whole square gives what? This is what? L1 L2 plus M1 M2 plus N1 N2 whole square. Now, so let's find A cross B now. So A cross B gives what? A cross B is equal to, so determinant ijk. So this is L1, L2, M1, N1. This is L2, M2, N2. So on expanding this, you get what? I into M1 N2 minus M2 N1 plus J into, instead of this I am going to take this first because I taken plus J, L2 N1 or N1 L2 minus L1 N2 plus K cap into L1 M2 minus L2 M1. This is your A cross B. Now A cross B whole square gives what? So magnitude of A cross B gives what actually? Magnitude of A cross B is what? Root of this, right? So when you square on both sides, so root get cancelled. So you get what? This one. You mean M1 N2 minus M2 N1 whole square, because root of A square plus B square plus C square, like that. You mean magnitude of this magnitude of this vector is nothing but root of this square plus this square plus this square. So I am taking square on both sides, so root get cancelled on the right side. So the remaining thing is this, you mean N1 L2 minus L1 N2 whole square plus L1 M2 minus L2 M1 whole square. Observe here, A cross B whole square, the value is this one, you mean this one, plus A dot B whole square value is this one. Sum of these two gives 1 in the second statement. Yes, of course, magnitude of A whole square. So A is what? L1I plus M1J plus N1K. So magnitude of this one is what? Root of L1 square plus M1 square plus N1 square, that is 1. Again magnitude of B, again magnitude of B is what? Root of L2 square plus M2 square plus N2 square, nothing but 1, because we have the result L square plus M square plus N square is equal to 1. So you get the result, I mean sum of these two you get 1, because these two have the same, I mean these two vectors have the same magnitude. So sum of these two, this is what the LHS of the second statement. Sum of these two gives, I mean the value of these two, I mean sum of these two becomes equal to 1, because these two, magnitude of these two vectors becomes 1. So product of these two is equal to 1. So we can say that for any two lines with cosines L1 M1 N1 and L2 M2 N2, so sum of these two becomes equal to 1. So then second statement also true. Then let us move on to third statement. The triplets 1 by 7, 4 by 7, 2 by 7 be the dash cosines of a line. So they can be or they cannot be. So how to check that? Just I mean we know the result that sum of the squares of all the cosines must be equal to 1. Let us check this. Yes, we have the cosines what? First cosine is what? First cosine is 1 by 7, 4 by 7, 2 by 7. So 1 by 7 square plus 1 by 7, 4 by 7 square and 2 by 7 square. So this will not be equal to 1. So for any 3 cosines, sum of the squares must be equal to 1. But in this case, in the third statement, we have cosines to 1 by 7, 4 by 7, 2 by 7. The sum of the squares never be equal to 1. So I can say statement 3 is wrong. So statement 1 is correct and statement 2 also correct, but statement 3 is wrong one. So our option is first option, first and second are correct statement. So option first is the correct one for 22nd one. Okay, let's move on to the question number 23. This 23 is like this. If A is minus 2, 3, 4, B is minus 4, 4, 6 and C is 4, 3, 5, D is 0, 1, 2. Then what is projection of AB on CD? Yes, projection of AB on CD. So this can be found using the result. Projection of vector A on B is given by what? A dot B divided by magnitude of B. This gives the projection of vector A on vector B. So that let's find AB and CD first. You mean the direction ratio. So this can be found. A dot B can be. Vector A. The components of vector A becomes what? Ratios of the line A, line AB. In this case AB, components become the ratios, and in case of CD also, components become the ratios. So that direction ratios of AB, or that's what, x2 minus x1. So here we have A minus 2, 3, 4, and B. So we have minus 4, 4, 6. In the same way, C we have C 4, 3, 5, and D is 0, 1, 2. Okay, now direction ratios of B. So x2 minus x1, you mean minus 4 minus of minus 2, that is minus 2. So minus 2 and 4 minus 3, 1, and 6 minus 4, that is 2. So these are the ratios of AB. Now let me find the direction ratios of CD. So they are given by same 0 minus x2 minus x1, that is what, minus 4, minus 2, minus 3. So these are the ratios of CD. Now the projection of AB on CD is given by what? Projection of AB on CD is given by AB dot CD whole divided by magnitude of CD. So this is what required. Okay. Before finding this, let me check whether these two are parallel or perpendicular. So there is a result for parallelism and perpendicularity. That is what, A1 A2 plus B1 B2 plus C1 C2 must be equal to 0. So now let's check this. Minus 2 minus 4, that is 8. 1 into minus 2, that is minus 2. So 2 into minus 3, that is minus 6. Of course, sum becomes 0. Whenever sum becomes 0, sum of the products of the ratios becomes 0, then we can say the two lines are perpendicular to each other. So whenever these two are perpendicular to each other, then the projection, so this is CD, this is AB, then AB, projection of AB on CD becomes 0. So there is no projection when angle between the two lines is 90 degree. So option first is the correct one. So before finding angle or anything by using the result what cos theta or sin theta, first you check whether they are parallel or perpendicular by using the conditions we have. This is the condition for perpendicularity, and one more result, that is what a1 by a2 that is equal to b1 by b2 that is equal to c1 by c2. This is what condition for parallelism. First check this, then you move on to finding angle or projection, whatever. So here angle between the lines is 90 degree, therefore projection becomes 0. So option first for 23rd question. Now let us move on to the question number 24th. The foot of the perpendicular from 573 to the line joining 9, 13, 15 and 12, 21, 10. So the foot of the perpendicular. So let us take, this is a perpendicular drawn on the line joining the 2 points. What are those? 9, 13. Let us take this one as A. 9, 13, 15, and this one as B, and the point is what? 12, 21, 10. So this is what from the line, I mean from the point of 5, 7, 3. So we have to find, anyway in the question they have mentioned this is perpendicular to this line, I mean this is perpendicular to the line joining these 2 points. Then what must be the foot of the perpendicular? This is what? That's question. So before finding this, let me check. There may be case that this might be A or B also. So how to check that? Anyway, they are perpendicular, no? Let me find what the ratios of these 2 lines, or yes, let us assume this is point A or point B. So first let us assume this is A, maybe, because anyway they have because they don't say A is anywhere on this line, right? Therefore, consider this foot of the perpendicular is A. Now let me find the ratios of AB as well as PA. So ratios of AB becomes what? Yes, ratios of AB, direction ratios of AB becomes what? Ratios of AB are 12 minus 9, that is 3, 21 minus 13, that is 8, 10 minus 15, so minus 5. These are the ratios of AB, and the ratios of PA or AP. Again, yes, PA or AP, whatever. Ratios of PA. So now 9 minus 5, that is again 4, 13 minus 7. So 13 minus 7 is 6, 15 minus 3, that is 12. So now anyway they have said that these 2 are perpendicular. So now let us check whether these 2 are perpendicular for these two for this for these ratios. Okay, I mean A1 A2 condition is what? A1 A2 plus B1 B2 plus C1 C2 must be equal to 0, right? So 3 4s are 12 plus 48. Yes, of course, becomes equal to 0. Yes. So let us take B in this place A. Then you check the same thing. You don't get the sum 0. You can check this. In place of A, we can take B also. Then now after that find the ratios of AB and PA, then check the condition, you don't get sum equal to 0. So you get the sum equal to 0, hence the foot of the perpendicular must be A. Foot of the perpendicular must be A. So anyway they have given these 2 are perpendicular, condition is satisfied, so A must be at this point. So option is A, A is option 4th is the correct option. Option 4, that is A itself is a foot of the perpendicular using the condition A1 A2 plus B1 B2 plus C1 C2 equal to 0. You can check by taking B also in place of A. So you don't get the sum equal to 0. So option 4 is the correct one. Okay, question number 25. 2 points are given, x1, y1, z1, x2, y2, z2 are the 2 points. So then the lengths of the projection, yes, this is what we have discussed about this in the last session. Projection of a line joining x1, y1, z1 and x2, y2, z2 on x-axis is always modulus of x2 minus x1, and on y-axis is always modulus of y2 minus y1, and z-axis, on z-axis is always z2 minus z1. So of course option A is correct one. So this is discussed in the last session. So so A is first one, A 1 is correct one, for B second 2 is correct one, C is 3 is correct one. So option first is the correct option for this. Okay, let me move 26th one. Vector equation of the line 6x minus 2 equal to 3y plus 1, that is equal to 2z minus 2. So hope you are all familiar in the equation of a line in vector form as well as in Cartesian form. That is what a vector form of the line passing through a point parallel to vector B is what? Vector A plus lambda B, where B is a parallel vector for this line and A is a position vector of the point through which this line passing. And this Cartesian form is what? X minus x1 by A is equal to y minus y1 by B, that is equal to z minus z1 by C is a Cartesian form. So this is the equation of a line passing through the points x1, y1, z1 with ratios a, b, c. Now this is actually this form, Cartesian form, but let us convert that into Cartesian form. So 6 into x minus 2 by 6, this is equal to 3 into y plus 1 by 3, that is equal to 2 into z minus 1. Now let me rewrite this, x minus 1 by 3, because 2 by 6 is 1 by 3, divided by 1 by 6 is equal to y minus of minus 1 by 3 divided by 1 by 3, and this is equal to z minus 1 by 1 by 2. So this is now of this form, Cartesian form, x minus x1, y minus y1, z minus z1 by, x minus x1 by a, b and c. So these are the ratios of this line. Now vector form is what? R is equal to a. So your vector form gives equal to a is what? Actually position vector of the point through which line passing. This is a line passing through 1 by 3 minus 1 by 3 and 1. So your position vector becomes what? Vector A is equal to 1 by 3 I cap, this is what? A plus lambda b. So this is equal to 1 by 3 I cap, so minus 1 by 3 j cap plus 1, so 1 k cap plus lambda into. So here we have the ratios, so 1 by 6 I cap plus 1 by 3 j cap plus 1 by 2 j cap, but we don't have these in any of the options, 1 by 6, 1 by 3, 1 by 2. So very simple, we have the ratios 1 by 6, 1 by 3 and 1 by 2. Let us multiply these by 6, then you get what? The ratios 1, 2 and 3. So now I can write, both are same, I can write I cap plus 2j cap plus 3k cap. This is your required vector form of this equation of line. This is Cartesian form and this is vector form. So option 3 is a correct one. Yes. So by using, Cartesian form is given. So using that we have found the vector equation. That's what option 3. Okay, let me move to question number 27. If the angle between the lines x plus 1 by 1 equal to y minus 1 by 2 equal to z minus 2 by 2 and the plane 2x minus y plus root of lambda z plus 4 equal to 0 such that sin theta is equal to 1 by 3, then the value of lambda. Okay, sine of the angle is given, sine of the angle between the plane and the line is given, that is what, 1 by 3. This is true for what value of lambda, that is the question. So, we observe the lambda, lambda is the coefficient of z in the given plane. Okay, so it is a simple one. We know that angle between line and the plane. Yes, here we have the line x plus 1 by 1, y minus 1 by 2, this is equal to z minus 1 by 2. This is your z minus 2 by 2, this is your line. So, this is parallel to, parallel vector for this line is what? Vector B is given by what? I cap plus 2j cap plus 2k cap. Using these ratios 1 to 2, I can get the vector parallel to the given line. Now, plane is given 2x minus y plus root of lambda z, I think, right? Root of lambda z plus 4 equal to 0. This is a given plane, and the normal to this plane is given by what? Yes, that is what, n. So, 2x, that is what, 2i cap plus, sorry, minus j cap, because coefficient of x is 2, 2i cap, 1 j cap plus z, coefficient of z is root of lambda k cap. This is your, when you write this in the vector form, you get what? R dot n, you mean this 2i minus j plus root of lambda k cap is equal to 0. R dot n, you mean you get this again, 2 into x minus 1 into y plus root of lambda into z. Okay. So, now we know that formula to find angle between a plane and the line, that is what? Sin theta is equal to b dot n divided by n. So, b dot n, that is what dot product of these two, you mean these two. So, a1 b1, 1 into 2, that is 2, sorry, a1 into a2, b1 into b2, that is 2 into minus 1, minus 2, plus c1 into c2. So, 2 into root lambda divided by, so a1 square plus b1 square plus c1 square. So, 1 plus 4 plus 4, 1 plus 4 plus 4 into root of 2 square minus 1 square plus root lambda whole square, you mean 4 plus 1 plus lambda, root of lambda whole square is lambda. This gives 2 times of lambda, and sin theta is given, that is what, 1 by 3 whole divided by, so 3 root 5 plus lambda. Okay. So, 3 get cancelled. So, 5 plus lambda or 2 lambda, 2 root lambda is equal to root of 5 plus lambda. Let me square on both sides. So, to remove the root symbol, so 4 lambda is equal to, so 5 plus lambda. This gives 3 lambda is equal to 5. So, lambda is equal to 5.3. Angle between the line and the plane, given plane, sine of the angle between these two is 1 by 3 only when lambda is 5 by 3. That is what, option 3. Okay, let me move question number 28. The point of intersection of the lines. The point of intersection of the lines. Here we have two lines, x minus 5 by 3, y minus 7 by minus 1 and z plus 2 by 1. And second line is x plus 3 by minus 36 equal to y minus 3 by 2, that is equal to z minus 6 by 4. We have to find point of intersection. You mean what? Point where the two lines intersect. That's what point of intersection. You mean point of intersection will be common for both the lines, right? When you consider these two are the given lines, this will be the point of intersection. Okay. Then let me find the point of intersection. Okay. So now, so this is a given line. I mean, these two are the given lines. Let me consider this one first. Here, I can take any point on this line. Any point on this line. So if I consider this one as is equal to some t, okay, then any point on this line becomes what? 3t plus 5, comma, minus t plus 7, comma, and t minus 2. This will be any point on this line, because when you substitute in place of x this, y this and z this, it becomes equal to t. See, in place of x 3t plus 5, 3t plus 5 minus 5, plus 5 minus 5 get cancelled, 3t by 3 t. In place of y, minus t plus 7, plus 7 minus 7 get cancelled, so minus t by minus 1, so t. In place of z, t minus 2, so plus 2 minus 2 get cancelled, so you get t by 1, that is what t. Okay, this is what any point on this line. Okay, now assume this is what the point of intersection. This is what the required point. Okay, so to get, to get required point, you have to find the value of t first. For that, what I am going to do, since it is common point for both the lines, let me substitute this. Let me plug in the values of x and y, z in this equation, because it must satisfy. Because this is a common point. This is a common point for both the lines. Since it is a common point, this should satisfy this given line. So let me substitute in place of x 3t plus 5. So 3t plus 5 plus 3. This is what x is 3t plus 5 plus 3 by minus 36 is equal to, in place of y, minus t plus 7 minus 3 divided by 2, that is equal to, in place of z, t minus 2 minus 6 by 4. Okay. So, on comparing any two, let us compare these two. So, you get what? Here minus t plus 4 by 2 equal to t minus 8 by 4. So, 1s are 2s are. So, you get what? Minus 2t plus, this into this 8 is equal to t minus 8. So, you get minus 3t is equal to minus 16. So, t is equal to 16 by 3. Okay. Now, let me substitute this t value in this point. So, you get what? 3 into t plus 5. 3t plus 5. 3 into t is what? 16 by 3 plus 5. X coordinate. Y coordinate is what? Minus 16 by 3. T 16 by 3 plus 7. And z coordinate is 16 by 3 minus 2. So, you get what? 16 plus 5, 21. This is what? 21 minus 16. That is 5 by 3. And 16 minus 6, that is 10 by 3. This is your required point of intersection. 21, 5 by 3 and 10 by 3 will be the required thing. Option 2 is the correct one. So, I think a simple one, very simple. In this case, you take this any point on the line. Since, after that, consider this is a required point, point of intersection. Since it is common for both the lines, substitute this in the second line, you get value of t, and substitute in this t, you get the required point. Okay, let's move on to the question number 29. The sine of the angle between the straight line and the plane. Yes, this is simple. I mean, the same type question we have discussed before. The line is what? X minus 2 by 3, y minus 3 by 4, that is equal to z minus 4 by 5. So from this, a line parallel to the vector 3i plus 4j plus 5k, this is what vector B, this is the line along this vector, and plane we have 2x minus 2y, plane we have 2x minus 2y plus z is equal to 5. So then this is a plane parallel to the, I mean normal to this plane is given by, yes, 2i cap minus 2j plus k cap is equal to 5. This is a normal to the given plane, sorry, that is what n. So your required angle is sine theta is equal to, so magnitude of b dot n whole divided by root of b into root of n. This gives what? Dot product of these two. So 2 into 3, a1, a2, 4 into minus 2, b1, b2, c1, c2, 5 into 1 whole divided by root of this, root of 3 square plus 4 square plus 5 square into root of 2 square minus 2 square plus 1. So you get what? 11 minus 8, that is 3 whole divided by, so 3 into, so this becomes 25 plus 25, that is root 50, 25 2 is so 5 root 2. So this cancel. Let me multiply by root 2, sorry, divide and multiply by root 2, you get what? Root 2 divided by 5 into root 2 into root 2. So root into root 2 is 2. So 5 2s are 10. So this is your required sine of the angle between the lines, given line and plane. So root 2 by 10. That is what option 4th is the correct one. Okay, let's move on to the question number 30. The direction ratios of a normal to the plane passing through 0, 0, 1, 0, 1, 2 and 1, 2, 3 are. So here there is a plane passing through 3 points. So plane passing through 3 points. Let me take, this is a plane. So this is a plane and this is a plane passing through 3 points. So let us take this point as 0, yes, 0, 0, 1, A. Let's take second point as B, 0, 1, 2, and C, third point, that is what? 1, 2, 3. So now we have to find what? The direction ratios of the normal to the plane. So yes, the normal is always perpendicular to the given plane, right? Okay. So this is what your normal. So before that, let me find AB and AC. Vector AB and AC. So vector AB and AC or line AB. Vector AB becomes what? x2 minus x1. So 0 minus 0, 0 I cap plus 1 minus 0, 1 j cap. So 2 minus 1, that is 1 k cap. This is your AB. And AC becomes what? AC is 1 minus 0, 2 minus 0 plus 2k. So using vector joining 2 points. Now these 3 points are in the same plane, right? And I have considered 2 vectors on the same plane. Now vector perpendicular to both the vectors, or the vector perpendicular plane is given by what actually? AB cross AC, right? AB cross AC will be the vector perpendicular to the plane containing these 3 points. So let me find that AB cross AC. Now AB cross AC is in the direction of n. So when you found AB cross AC, so the ratios of this AB cross will be the ratios of the normal, because the normal is in the direction of AB cross AC. So now we have to find what? AB cross AC. So AB cross AC is given by, hope you got it, students. So normal vector is perpendicular to the plane containing these 3 points, and also AB cross AC is also vector perpendicular to the plane containing these 3 points. So then I can say n vector, I mean normal is in the direction of AB cross AC. So then I can say the ratios of AB cross AC will be the ratios of n. So now AB cross AC becomes what? IJK. So coefficients A1, B1, C1, A1, B1, C1, A2, B2, C2. So you get what? I into 0, this minus this, plus j into this minus this, plus k into so 0 minus 1. So you get what? 0 I cap plus j cap, 1 j cap minus k cap. So you mean the ratios of the normal are given by 0, 1 and minus 1. So these are the required ratios of the normal. Since AB cross AC is in the direction of n cap, or n cap is in the direction of AB cross AC, I can say these 3 are the ratios of the normal. You mean option first is the correct one. 0, 1, minus 1. Okay, now let's move on to the question number 32. The coordinates of the foot of the perpendicular drawn from the point P 103 to the line joining the points 471 and B. A is 471, B and B is 353. Yes, here we have to find the coordinates of the line joining. Yes, the coordinates of the foot of the perpendicular. Yes. So this is what? P103, 103 and A. So A is given, that is what? 471 and B 353. So the same type of question we discussed before. So there we have got A itself, even A will be the foot of the perpendicular, but here, so that's not true. So then how to find the foot of the perpendicular? So now anyway, there is a line AB passing through 2 points. Now let us write equation of AB. So AB is given by what? Passing through 2 points, no? So equation of a line passing through 2 points is given by what actually? X minus x1 by x2 minus x1. So x minus x1 is what? 4, x2 minus x1, 3 minus 4, y minus y1, y minus y1, so y2 minus y1, 5 minus 7, z minus z1, z2 minus z1, so 3 minus 1, 3 is 2. Now this is what equation of AB, equation of AB now. Now let us take, minus t plus 4, minus 2t plus 7, and 2t plus 1 be any point on this line. Let us take this is equal to some t. So we have discussed this before. In place of x, if you substitute this minus t plus 4, so plus 4 minus 4 get cancelled, minus t by t, minus t by minus 1, so that is equal to t. In the same way, minus 2t plus 7, you get t. Again, in place of z, you substitute this, you get again equal to t. Now, this is what the required point. Assume this is the required point t, I mean your foot of the perpendicular. Let me take this one as q. Okay. So, now since they are perpendicular and we have the ratios of the line joining AB, that is what minus 1, minus 2, minus 1, minus 2, 2 are the ratios of the line joining AB. Let me find the ratios of line joining these two. Let us take this one as x1, y1, z1, this one as x2, y2, z2. You mean this is what, nothing but q now. X2 minus x1. So, ratios of direction, ratios of PQ. What now? This minus this, you mean minus t plus 4 minus 1. So, minus t plus 3, minus 2t plus 7 minus 0, minus 2t plus 7 and 2t plus 1 minus 3. So, 2t minus 2. So, these are the ratios, direction ratios of PQ. Direction ratios of PQ. Okay. So, since now these two are perpendicular, they only said that, I mean we are finding what actually the foot of the perpendicular. No? So, these two are perpendicular to each other. Since they are perpendicular to each other, so there is a result that what A1 A2 plus B1 B2 plus C1 C2 must be equal to 0. You mean A1 B1 C1 are the ratios of AB and A2 B2 C2 are the ratios of PQ. Now, let me substitute, this is A1 B1 C2 minus 1 into this minus t plus 3 plus B1 B2. So, minus 2 into minus 2t plus 7 and C1 C2. So, plus 2 into 2t minus 2, that must be equal to 0, right. So, now let me simplify this, t minus 3 plus 4t minus 14, right. So, plus 4t minus 4 equal to 0. So, now 4t plus t, this is what 9t equal to minus 14 minus 18 minus 21, that is equal to 21. So, t is what 21 by 9, that is 7 by 3. Okay. So, t is 7 by 3. Let me substitute that value in this, you get the required point. So, your required point will be equal to what? Minus t, minus 7 by 3 plus 4 minus 2 into 7 by 3. So, minus 14 by 3 plus 7, 14 by 3 plus 1. So, your required point is 3 4s are 12, 12 minus 5. So, 3 7s are 21, next 3 1s are 3, 3 plus 14, 17 by 3. So, 5 by 3, 7 by 3, 17 by 3. Yes, option 2 is the correct one. 5 by 3, 7 by 3 and 17 by 3 is the required foot of the perpendicular. It is very simple, students. First what I did, I considered a line passing through these 2 points using the line passing through 2 points. After that, considered any point on this line and I taken this one as Q, and after that I found ratios of both the lines using this condition for t value. So, this is the required one. Okay. Okay, let us move to question number 33. The line x minus 3 by 3 equal to equal to y minus 2 by 1 equal to z minus 1 by 0 is what among the 4 options? Parallel to x axis, parallel to y axis, parallel to z axis, and perpendicular to z axis. Okay, here this is a line with ratios 3, 1 to 0. So ratios are given by, so direction ratios are 3, 1, 0. Let me write the vector form of this. R is equal to 3i plus j plus 0k. Okay, this is vector form of this ratios 3, 1, 0. Now look into the first option, that is what? Parallel to x axis. When this is parallel to x axis, what happens? In the first case, R will include, this vector will include what? I component only. Only I component, but here we have I as well as j. Okay, therefore first option is not correct. So it's very important, whenever it is parallel to x axis, the R vector has only I component. Okay, so it includes only I component, but here I as well as j component, so first option is wrong. In the second option, parallel to z axis, right? Sorry, parallel to y axis. In this case, R will include only j component. So, but here we have I as well as j. So second option is also wrong. In the third case, R will include only k component, but k is 0. Okay. And last one, perpendicular to z axis. So whenever this line is perpendicular to z axis, what happens? Z axis, no, R dot k must be equal to 0, right? Whenever it is perpendicular to z axis, R dot k must be equal to 0. So now what is R actually? Here we have 3i plus j dot k must be equal to 0. Let me check the value. So 3i into k. So 3 into I dot k plus j dot k. So 3 into I dot k is 0 plus j dot k is also 0. So your answer is 0. Of course, whenever this required line is perpendicular to z axis, then this should happen. R dot k must be equal to 0. As this happens, therefore option 4 is the correct one. You mean the given line is perpendicular to z axis. Okay, let us move to question number 34. The length of the projection of the line joining the points 3, 4, 5 and 4, 6, 3 and the line joining the points minus 1, 2, 4, 1, 0, 5. A simple one. Here we have two lines passing through two given lines. 3, 4, 5, 4, 6, 3. 3, 4, 5, 4, 6, 3 is a line. First line passing through these 2 points. Let me take A and B. Second line passes through points minus 1, 2, 4 and D, 1, 0, 5. Same, let me find vectors AB and CD. The lines ratios of the lines AB. What? 4 minus 3, 6 minus 4, 3 minus 5. You mean AB, line AB will have the ratios 1, 2, minus 2. In CD, 1 minus half minus 1, 0 minus 2 and 5 minus 4. So now CD will have the ratios 2, minus 2, 1. Now projection of AB on CD is given by what? Projection of AB on CD is equal to what actually? So AB dot CD whole divided by magnitude of CD. This gives your answer. AB dot CD. So you mean cross dot product of these two. 1 into 2, 2. 2 into minus 2, minus 4, minus 2 divided by. So we get root of CD, 2 square plus 2 square plus 1. So that is what, a root 9 I think. So you get minus yes. So you get what, 4 by 3. So 4 by 3 is the correct option, that is option first. Okay, let me move question number 35. The point of intersection of the line and the plane. Here we have line x plus 1 by 1 equal to y plus 3 by 3 equal to z minus 2 by minus 2. This is the given line, and the plane is given by 3x plus 4y plus 5z is equal to 25. This is your plane. Yes, same as before. You have to find point of intersection. You mean the point where the point where both the plane and line intersect, right? So this is to be found. Okay, for example, like this. This is a plane. This is your line. So this is what we call as point of intersection. Okay, you have to find point of intersection now. So let me take, here we have t minus 1, because this is equal to some t, assume t minus 1 and 3t minus 3, okay, and minus 2t plus 2 be any point on the given line, because it satisfies the given line. In place of x, t minus 1, so 1 plus 1 minus 1 get cancelled, you get t. Again here plus 3 minus 3 get cancelled, 3t by 3 t, minus 2 plus 2 get cancelled, minus 2t by minus 2, that is t. Now assume this is a required point. This is your point of intersection. You mean t minus 1, 3t minus 3, minus 2t plus 2 now. Since it is common for both line as well as plane now, because it's a point of intersection in the sense it is common for both the plane as well as line. Okay, so now it is on plane also, it should satisfy this plane now. So you mean replace x by x coordinate, you mean t minus 1 plus y into 3t minus 3 plus 5 into z coordinate is minus 2t plus 2 is equal to 25. So you get 3t minus 3 plus 12t minus 12 minus 10t plus 10 equal to 25. 3t, 15t and minus 10t. So that is what, 5t. So minus 3 minus 15 plus 10. So minus 5, take to right side, become plus 5, that is 30. So t is equal to 6 I think, right? t is 6. Now substitute this t in this required. So required point of intersection is t minus 1, 6 minus 1, that is 5, 3t minus 3, so 3 into 6 minus 3, and minus 2 into 6 plus 2. So you get 5, 15 minus 12 minus 10, I think. So 5, 15 minus 10. So that is option, yes, 5, 15 minus 10 is the third option, and third option is the correct one. The point of intersection of both the line as well as plane. So 5, 15 minus 10. Okay, let us move to question number 36. The distance of the point 2, 3, minus 4 from the point of intersection of the lines and the plane. Yes, the distance of the point 2, 3, minus 4 from the point of intersection of the given x line, that is x minus 1 by 3 equal to y minus 2 by 2, that is equal to z plus 1 by 1, is a given line. 2x plus 3y minus z minus 20 is a given plane. So a simple one. Yes, here same as before. Here we have a line. What is that? X minus 1 by 3. X minus 1 by 3. That is equal to y minus 2 by 2. That is equal to z plus 1 by 1. This is our given line. So let me take any point on this line. Any point on this line is 3t, if it is equal to t, 3t plus 1, 2t plus 2, so t minus 1. This is your point. Okay. So you have to find the distance of the point from the point of intersection. So first let us find point of intersection of both line and plane. Since it is common for both point, the line as well as plane, so it must satisfy the plane also. The plane is what? 2x plus 3y minus z minus 20 is equal to 0. So this must, this point must satisfy this one. So let me substitute 2 into x, 3t plus 1 plus 3 into 2t plus 2 minus z, that is what, t minus 1 minus 20 equal to 0. 60 plus 2 plus 60 plus 6 minus t plus 1 minus 20 equal to 0. 60, 12t, so 11t, 2 plus 6, 8, 1, 9 is equal to 11, so t is 1. Okay, so t is get 1. So then your point of intersection becomes what? Your point of intersection is 3 into 1, that is 4, 3 into 1 plus 1, that is 2 into 1 plus 2, that is 4. This is 0. You mean this is your point of intersection of the lines and the plane. So now you have to find distance between. So point is what actually? Point is 2, 3, 4. Let me take P. 2, 3, 4. 2, 3 minus 4. And this is the point of intersection. This is the point of intersection of the lines and line and the plane. That's what we have got, 4, 4, 0. So distance between these two. So using distance formula, we can find PQ is root of x2 minus x1 whole square, 4 minus 2, 2 square, 4 minus 3, 1 square, 0 minus of, so that is what, 16. So you get what, root 21. So root 21 is the required distance between point 2, 3, minus 4 and the point of intersection of the given plane and the line. So that is option 3 is the correct one, root 21. Okay, let me move to question number 37. Equation of line through minus 1, 2, 3 and parallel to. Equation of line through this and parallel to the given line. Since it is parallel to the given line, I mean the required line is parallel to the given line. So ratios must be same. That is what, 2 minus 3, 8. So look at the ratios. In the first and second option, we have the same ratios, right? In place of A, B, C, 2 minus 3, 8. So then first and second, maybe, I mean among these two, you answer, I mean option is among first and second. So now the line is passing through minus 1, 2, 3, right? You mean x minus x1. This is what, x1, y1, z1. So required line passes through. I mean required line is x minus x1. X minus of minus 1, that is x plus 1 by ratio is what? Ratio is what? 2. Okay, y minus y1. So y minus 2 by ratio is minus 3. And z minus z1. So z minus 3 by ratio, that is what, minus 8. So this is your required answer. You mean option 2 is the correct one. The required line passes through minus 1, 2, 3 and having the same ratios 2 minus 3, 8. Therefore, this will be the required answer. So option 2. Okay, let me move question number 38. The distance between the line and the plane. So here we have line R is equal to 2i minus 2j plus 3k plus lambda into I minus j plus 4k. I minus j plus 4k. This is your given line, and the plane is, so this is your plane r dot I plus phi j plus k is equal to phi. This is your plane. So you need to find the distance between these two, plane and the line. And this is a line passes through what? 2 minus 2, 3. So this is a position vector of the this is a position vector of a point through which this line passing, since this is a required point. I mean this line is passing through this this point, and this is parallel to the vector, right? Okay, now this is, I mean here we have normal vector, that is what, I plus phi j plus k. Okay, now this is your plane, this is your normal, this is what, I plus phi j plus k. Now the line, sorry, okay, let us take line. Line is in the direction of this, right? Okay, so let me check the product, I mean the coefficient, the product of the coefficient of these two. You mean this and this. You mean I am checking the condition for condition of what, a1 a2 plus b1 b2 plus c1 c2. So what is a1 a2? So 1 into 1, you get 1. So 5 into minus 1, minus 5. So 1 into 4, so that is 4. So of course you get 0. You mean, so this is become, I mean this is I mean A1 A2 plus B1 B2 plus C1 C2 is equal to 0 in the sense B and normal vectors are perpendicular. In the sense line is perpendicular to the normal and this is in the direction of B. So I can say line and the plane are parallel now. Hope you got it. Since vector B, I mean the given line and the normal are perpendicular, by checking this you get 0. This is a condition for perpendicularity. Since the line is perpendicular to normal, I can say line and the plane are parallel. So now I can find the distance between these two. Yes. So we have to find what actually the distance. Yes, the distance between the line and the plane, right? Okay. So now this is a line passed through this point. What? 2, minus 2 and 3. And this is your plane. I can write plane as what? I can write in Cartesian form as what? X plus 5y plus z is equal to 5. This is your plane. Now equation distance between these two gives the required answer. When using the formula, that is what? Distance is equal to x1 plus by1 plus cz1 minus b whole divided by root of a square plus b square plus c square. This is your required distance. So required distance. Now a is 1, b is 5. I mean capital letters. Capital A is 1, b is 5, and c is 1, d is 5. Okay. Substitute this. You get what? X1 is 2, y1 is minus 2, z1 is 3. Ax1, so 1 into 2, 2, by1 minus 2 into 5, understand? So 3 into z1, you mean 3 into c, so you get 1, so 3 minus d is what? 5 divided by root of a square plus b square plus a square is 1 square, b square is 25, c square is 1. So you get what? Yes, 2 plus 3, 5, 5 get cancelled, minus 10. You mean 10 divided by root 27. You mean 10 divided by 3 root 3. So 10 divided by root 3 root 3 is required distance between the given plane and the line. So option 4th is the correct one. Okay. So this is about today's class. In the next session, let me continue from question number 39. Okay. Thank you.